Okay, let's get going. So, we're going to work on TAUFRAG, the common functions for the Tau system. Tau for texture as uniform. No relation to pi multiplied by 2. Okay, so let's go to our dashboard. And let's just keep our dashboard open so that we can see if anyone is chatting with us, blah, blah, blah. And we're not doing 175, we're doing 177, and it is TAUFRAG. Okay. And it's not going to be just chatting, it's science and technology. So let's change that, science and technology. Okay, so let's just hit done, and let's update that, right? So let's update that, and now that we've gotten that out of the way, let's take off our sweater, because our body can't regulate temperature, so it fluctuates wildly. Drink 1 cup of cocoa, and then we're too hot, and, you know, then later we're going to be too cold. Like, life is hard, man, right? Okay, so let's go put this, I don't know why it says 0, but let's go put that up there where we can see it. And let's start opening stuff. So, first of all, let's open, does this shortcut not work? Is this not a thing? Oh, wait, because we gotta open, okay, Windows E, AAC 2020 folder, right? So let's go open up the project folder for our C code. Let's put this over on this side. Let's open the common code we want to look at. So in TAUFRAG, right? TAUFRAG, all this stuff is what we want to be looking at. Let's just split this off into another window so we have some split screen action going here. Okay, cool. So how many minutes do we waste? Like, okay, it took us kind of 3 minutes to get all situated. Keep that in mind. Context switching has a cost. So before we continue, before we go any further, we want to make sure that this compiles, or if it doesn't compile, figure out what's going on. But if I was a good person, then this will compile out of the box, right? Because I try not to commit things in a broken state, but you never know, sometimes I screw up. So, okay, so it seems like my hard disk was being... Wow, it says my bitrate is absolutely nothing. What's up with this? Can we, can I refresh my stream manager? Because maybe that's not... That doesn't look right. Okay, cool. So this is up and running. And we want to do some refactoring here. So let's get at it. So we got TAUFRAG, and you notice that we have some shorthand constants like tau this, tau that, right? You have these shorthand constants, and then these other shorthand constants, and we'd like to use these directly. However, we're going to undefine the constants after we're outside of this code, because since they're very short constants, they can leak into other code and wreck the compilation of other code, which they already have, and that's why I already have them undefined here, because they were leaking into other code and messing with our day. So what we're going to do is we're going to take code in our fragment shader that renders the tile sets, and we're going to put it into here, right? And maybe not directly into here. Maybe we'll make some type of wrapper functions or something. I don't know exactly what we're going to do, but we're going to figure it out. So let's go over here. And let's go open up the PAINT5D shader. So, actually, no. We wanted to look at FragCom, right? Okay. So in fragcom, we should have some helper functions, or maybe we don't. We have some mapping functions. Okay, well, you know what? We'll address things as we get to them. So, okay, so here's the shader code for the PAINT5D system. And we want to look where we have some hard-coded stuff, and we want to unhard-code it out. So the hard coding is pretty obvious because we made it so that, right, so we have a justification like this so that we can see where things need to be addressed, right? So you can just scroll through here really quick and see the little flash, and you're like, oh, what's that? All right, and then you can be like, oh, that must need attention. And indeed it says, you know, fix these hard-coded values. Okay. So we have like a get rec tau depot get rec get u32. So the question is, do these functions belong in the PAINT5D system, right? Get rec and get u32. Let's go look at them for a second. So I think that the get rec functions actually belong in TAUFRAG. And then this pixdex thing needs to be I mean, if that's what we do, then we have to change how this works. Because it's like a wrapper function. Well, let's go steal some code. So, tau depot pixdex, right? Well, this is TAUFRAG, right? So what I'm saying is that this right here, let's try to refactor one thing at a time, okay? So, first thing we're going to do is we're going to have a breakpoint right here, right? And we're going to steal this, right? We're going to steal this code, copy it, and we're going to paste it in here. Okay, so now we have this function, and we're going to, we could keep a to-do that we need to unit test this function. But let's actually do something a little bit different here. So in here, let's just say, you know, if, and then if it's not OpenGL code, right? So we have a macro for if it's OpenGL code or not somewhere. And it's not in here. It is, so up here we have one of the macros. Oh. If def AAC 2020 macro, this is OpenGL, right? So if ndef, okay, so if it's not defined, then we're going to do some stuff. 1, 2, 3, 4, okay. And then ndef. Okay, so if we're inside of here, and we're not running as OpenGL code, we're going to say AAC 2020, to-do man vital need unit tests. Nuts. There we go. Alright, so we need a unit test for this code. We'll just call it nuts for need unit test. We can also make a time for this, right? At vid id. And keep track of, like, when did we add this code, right? So right now the video is number 177, right? So, crap. So video 177, and the time is 0010, and let's do 42 because we want to be cool. Okay. So we want to change this namespace. We'll leave the current function here until we get this function changed up enough. We could really just call it TAUFRAG pixdex, right? And then we can make some notes in here. Like, if we want some notes about the function. 1, 2, 3, 4. Originally, it was called so the original name was this, right? We can keep track of the original name. And that's really the only thing I want in this little about section. Okay, and so you notice that I put the abouts for the code for the function, not at the top of the function, but actually inside the function at the beginning of the function in the beginning. I put the about in the top of the body of the function rather than on the top of the function. Now, IntelliSense tools don't work that way, but I like it visually just because I don't like having clutter on top of these declarations here, right? I personally think that an explanation about what a function does is more information than I want when I'm scanning through, right? At the very top level, I just want to know, hey, what are my functions, what do they take, and what's their types, right? If I want more information, like, this commentary, as far as I'm concerned, is part of the nitty-gritty details of the function, right? Like, what the function does is more detail than the prototype. So the prototype, so in order of levels of detail of what I want to know the prototype, then I want to know a summary of the function, and then I want to know the nitty-gritty details. But to take this right here and put it at the top of the function means that we're going to see things out of order in terms of the hierarchy of what nitty-gritty details I want to see at what points in time, if that makes sense. Okay, so we have this function. We've just kind of stubbed it in here. We're not expecting anything to happen yet, right? We're just trying to refactor this out of here. So the first thing we're going to do is we're just going to double-click and see if this compiles or see if we need to fix some stuff. Because we just pasted it in there, right? I don't know what's going to happen. I mean, maybe it'll work, maybe it won't. Okay, so unknown type name int32. So the reason for that is this is going to require some of our typical defines. And these defines are... this whole file is going to get stringified, so we can't use includes, right? It would be nice to just use includes and not have to cut paste stuff, but we can't get away with that, right? So what we're going to do here is just say TAUFRAG type def TAUFRAG defines go here. Okay, so let's just make another section. And I don't know how I want to do this, but I do like things lining up, so we'll do it like that. So we need a section for defines here, but then we also need to go at the very bottom here. And we need to undefine the same defines, right? So we're going to say, like, you know, if... actually, no. If def, right? And then, is this the same order that we did it in the other code? Like, how do we usually do it, right? So if we look at some other code, right? So if def, when running as GLSL code, right? So, okay, else, okay, and then over here we're just going to say running as C99, right? I'm just OCD, so I'm just going to put an underscore in front of this so that it just lines up. That's the only reason, right? I do some things for weird reasons that... Some things I do are just kind of like... It shouldn't matter, but I do it anyways. Okay, so we're going to define int32. We're going to define things in terms of what we actually need, right? So we could just cut-paste all of this, but I think we should just do it on a case-by-case basis, rather than have, like, the whole point of being able to do these macros on a file-by-file level is so that we don't have to cut and paste a whole bunch of stuff and get a whole bunch of, like, macro technical debt. So let's only do the things that we actually need, right? So int32 in GLSL is just an int, right? But when it is in our C99 code, then it's one of these, right? So define int32 is this. So I don't know what we want to line up here. I guess int lining up with int32 might make sense. Okay, so we have int, and I'm certain that there's probably other variable types running around in here somewhere. Or maybe not. Maybe we don't have any unsigned integers. Maybe that's all we have. Actually, no, that's all we have. Oh, actually, we have make float32, though. So I'm going to say... I do like it written like that, right? Because then we just say make float32. But I am also kind of sick of this being kind of long like that, right? Because then we have these two different sections. So... let's just do it. If you know, let's just go with our whim, right? If that's how we want to do it. MF3. AKA. I'm gonna just try to make this UN terser because I would like to just be able to use things more shorthand, right? So then over here, we're going to define MF3. MF3 here, however, is going to be, right, if it's not GLSL code, we have to say make int32. So here's our polyfill for, actually, no, not make int32. Make float32. So this make float32 here, right? So make float32, make float32, make float32. If it's GLSL, we just use float because it can be used in a constructor kind of way. But when it's C99 code, it can't be used that way. So, okay, so we got this MF3 thing. And then over here in this code that we kind of pasted, we're just going to say MF3, 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 and MF3, right? And will we regret being this terse? Possibly, yes. Possibly we will regret this, and we'll be like, this was a stupid idea. Why were we so terse with ourselves? Blah blah blah. But for now, For now, let's not worry about it. For now, let's assume that we know what we're doing and that it's a good idea. So do these numbers need to match up? It kind of seems like maybe it does. Oh, I see. Sure, okay. So that's kind of refactored. So the make N32, let's change that as well, right? So over here, we have the define make I3, right, for int 32. And that will be just int. And then we'll just say aka make int 32. And then over here, we'll define make int 32 mi3. And we have this make int 32 macro right over here, right? Or not macro, but we have this kind of polyfill function. So make int 32, make float 32. Make int 32, make float 32. Okay, so int and float. Okay, so that looks good. And then we're going to go find this, right? So we're going to go find this one here. And this is where we're going to just change this. So this is going to be bam, bam, bam. So even terser. So let's, we can now kind of backspace up a little bit more here. Okay. And also this true thing, I don't know where true is defined in here, but I'm sure it's defined somewhere in here. Let's match the case. Maybe we need to match whole word as well. True, oh, true is trunk. So it's shorthand for trunk. I thought it was shorthand for Boolean. That actually makes more sense. Define true as trunk. Like floor. Like floor, it's not quite a floor, but you could think of it as flooring if you wanted to. Usually, flooring goes towards 0. Truncation just takes off everything off the decimal. So usually they're the same. If they're positive numbers, flooring and truncation are the same thing. But once you go negative, then flooring and truncation are not the same thing. So it's important to know that. Okay, so this truncation here, I will also have this polyfill for truncation. Is there anything else we need? I don't know. Let's just keep on going through here and see. Okay, so I think we have all the macros we need for this. Now the next thing is we need to, we should take some checksums, right, of this kind of stuff here, and make it so that we want to make it so that okay. Okay, so we just want to make it so that we can see this little checksum here, so that we know, hey, we got 4 things we have 4 things we need to undefine, right? So then over here, we're just going to go undef, right? And we're going to try to keep the exact same formatting. So let's, do you want to keep the same coloring as well? I don't know. Sure, why not? Okay, right, so we undef those, that's good, except there's one problem here. Undef needs 2 spaces after it. So I know this is kind of weird, but this is not aligned, right? So you can see they were off by 1 here, right? You see how the int32 has the space before it? You see the spaces before all these macros? If you go down here, you don't see that space. So this actually needs to be like that. So undef and define differ by one letter, and that's why we need it like that. So I know a lot of things I do are just like overkill aligned, but that's the way I like things. So okay, so if def error macro names must be identified. If def 1711, huh? Okay, well let's go look at this. Error, macro names must be identifiers. Macro names must be identifiers. If def, wrong. If def, my example macro. Oh, I see. Okay, so if I want to write it like this, I can write it like this, but I have to do something like this. If defined. I would like to keep my parentheses, so if I want to keep my parentheses, I have to write it this way. It turns out I've made this mistake before, and I have shortcuts that told me exactly what I did wrong. So let's see if that tip helps me if I have the correct syntax now, or if that tip was. I know what I'm doing wrong now, but hopefully the solution was correct. If and def. Okay, yeah. So this fixed it here, and I have to go down to 147 and do the same thing, right? So in 147, we've probably made the same kind of mistake. Yeah. So if not defined, if not defined C99. I don't know what the not defined version is. Preprocessor check if multiple defines are not defined. If n. Oh, if n. Okay, if n. So it's a if n. So I want to make a note of that, because that's kind of useful. So okay. So looking at that, we should just be able to say if n, right? So if n defined, and so basically what I'm saying is if this is not compiled as OpenGL code, if it's being compiled as C99 code, then I can use my to-do manager to say, hey, I really want some unit tests for this code, right? So that's what that's about. Okay, so let's see if those kind of macros are. Also, I should be kind of careful because, like, just because they work in invalid preprocessing directory, if n. Okay, so if n is not a thing. Wait. Wait. Okay, so we don't have if n, but we might have if not defined like that. We might be able to do that. 147. So let's try that. And okay, so that worked. Okay, hold on. Okay, cool. So that worked. So I just want to make some notes here. Okay, I was just making some notes. Okay, cool. So okay, so this is now in the code base. So what we're hoping now is that pixtex thing here. We eventually want to get rid of this, right? We eventually want to say, hey, you know what? You know what? This thing I don't care much for, right? So hopefully we didn't already write a unit test for it, because if we didn't, then we don't have to do as much refactoring. So okay, so this might be important to know. So there's CPU side code for this, and that's what it's called. Might be important to know that. Okay, yeah, but as far as I'm concerned, anywhere where this is being called right now, we should be able to refactor it out for the TAUFRAG now. Okay, not exactly. There's some more stuff we're going to have to do before that works. But one thing at a time here, right? So we're going to look for where we can find... We're going to find this. Okay, we replaced all the sites. So this is going to fail. The compilation is going to fail us because the function we just replaced right here, it's not being included in that shader string yet. And that's okay. We'll fix that. But first we want some confirmation that indeed the shader just is not going to compile. Right? We want to confirm that it does not work before we fix it, because we want some sanity. We want a sanity check that the code we're writing actually does have some bearing on the compilation, right? So we have a syntax error. Okay, cool. And now does it say, what does it say though? Undefined variable TAUFRAG pixdex. So so that is kind of what I expected, or something similarly saying that, hey, that function does not actually exist, right? So then what we want to do is we want to go open the default shader for the PAINT5D. So PAINT5D default shader, that's the shader we're looking at. And if we go open this up, we see, oh, hey, look, we include fragcom.fra.string, right, for fragment shader common code. But then after the fragment shader code, we now want to include another thing called TAUFRAG, right? Okay. And now if we include all these, we'll be in good standing, except that this does not exist yet because we have to add that into our build system. So you'll see it'll say like some file doesn't exist type of error. I don't know what the error will say exactly, but it's going to say that this file does not exist yet. So file included libcham, blah, 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 fatal error right here. No such file in the directory. So we got to fix that as well. So to fix that, we're going to go open our build script. And let's go put the build script on the other side so that we can kind of look at this code here while we're looking at the build script. And in here we have, okay, create build system executables. Okay, this is for the PNG hex dumper, right? So we actually compile the hex dumper library. We actually compile the hex dumper library as a separate executable. The hex dumper is also put into the final executable, but it's also compiled standalone as well, because we use it to bootstrap getting other assets into the code, right? So right after we compile the hex dumper, we use it to generate some hard-coded assets, and then delete old shaders. Okay, I'm fine with that, because I got sick of manually deleting these. So, okay, so generate GLSL code from C99 code. So we're just using the awk command, which executes on every single line except for blank lines. I don't know what NF means, but it basically will skip lines that are blank. And then within these curly brackets is the command to execute. And it just takes the current line. So this is the current line, and it just wraps it in quote characters. So, and the input file, right? The input file and the output file. So we kind of made the input file and the output file variables so that we could kind of like see a very obvious pattern here, right? With the in and the out, and also just keep our lines pretty short. So now that we have this, we just want to say, okay, we got fragcom, so let's kind of, the order of this does not actually matter, the order in which we stringify this. But let's just say fragcom, and then TAUFRAG will go here, right? So TAUFRAG. So we got TAUFRAG, fragcom, GPU view, P5D, whatever the heck. Okay, so let's take that, let's try to build now. So I'm anticipating that we get further along in the build. I don't know what's going to happen next, but we're going to get further. Not undeclared here, not... Okay, so we did the thing where we were kind of stupid here. So in TAUFRAG, we have to remember that TAUFRAG is being wrapped inside of a shader string, and because of that, any type of shader code we write cannot contain any quote characters. To get around that, we have a stringify no quotes macro. Quotify macro. Error string macro. create error string without using quotes. Unquoted string. Non-quoted string. Non-quoted string. I didn't spell quoted correctly in there, so let's just kind of like do that again. Quoted. Quoted. String without quotes. Strings without quotes. So we're just making some synonyms. No quote string. No quote macro. Okay. So we got all these synonyms and whatnot. And in one of our shaders, we already have... We can close this. I think that's good. Let's make sure we still have this here, because we're eventually going to get rid of this. This thing here, we're eventually going to get rid of this function. But before we do that, we should have a macro called ES for error string, I believe. Yeah, ES. So error ES, 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 ES. So undef ES and ES private. Okay, so here we go. So here's the error message. Here's the error string macro, which calls error string private, and it just uses the stringify operator on the error message, right? That's all it is. It's pretty simple stuff. So what we're going to do is we're going to make this into like a little snippet here. So it looks like this is kind of like indented twice. So I'm going to assume that's kind of like where we're going to need it indented for the future. And shortcut error strmac. Let's just call it error strmac. And then I don't know what we want to do. Let's change the language for a second so we can see. Yeah, so this is the shortcut for this code right here. I don't know exactly how we want to do this, but I was thinking, you know, maybe we want to encapsulate it kind of nicely like this, so it's kind of like this chunk that's where it's ready to throw into our shader code. It's formatted for that, right? So we're going to take this and error strmac, right? So we're going to take this and we're going to go into the AutoHotkey folder. We're going to go find the shortcuts. We're going to go find the shortcut files, cxx, C any language, and then we're going to go nope, just call it error string macro. Let's call it ESM for error string macro, and then we'll just ES, whatever. Full file path to clipboard. So we're going to take this. We're going to put it right here. Paste file. Alright. Right here we'll run remove dupes. If this still works, because I knew that a while ago it was broken. Total, okay, so there were no duplicates, but I just wanted to make sure. And then we're just going to go barg. And then also, you know, since it's called ESM, since the file name is called ESM, we might as well say paste ESM paste. And then, you know, we could also make a note here that, you know, ESM means, right? And then we can make a note, ESM is error string macro, right? Okay. Yes means, or ES means, or ES means equal size. Okay, we'll just not do that one. So ES airstring. Okay. So we're going to take this and we're going to put it in our master shortcuts file. We're just going to paste it into our master shortcuts so that, you know, next time we want to do this, we don't have to take so much time to find it. Okay. So with that, let's open up that file again really quick and pretend that we have it as a shortcut. We'll just place it to our clipboard and then just insert it where it needs to be inserted, right? So we need this thing here, but we need to actually just call the airstring directly in here like this. So we want to go like ES airstring, and then we call it like that. Okay. And then we want to go up and find where we're declaring all this macro nonsense, right? So here we have these macros here. Always exist airstring macros. So it's the same no matter what. So do we want to... so let's just make a section, same in both languages macros, if we can do that. Let's call it ESPri for airstring private. And let's whittle down this line hierarchy and make these lines a little bit less dense because they're kind of nested within this area here, right? Okay. So still, if we need this, if we want to really, you know, let's call it ESP just because that amuses me. And that will give us the amount of space we need to finally kind of fit this in here where it needs to be, right? To get this kind of all nicely aligned. So then if we do that, I think we have... oh, I see. Uh-huh. So... I don't know. Is it the best? Did we do the best job categorize? I don't know. Whatever. Let's not worry too much about it. Maybe we got a little bit too designy. So same in both language macros. Sure. Okay. ESP. Okay. Make a note of what ESP actually stands for. Okay, cool. So now that we have this ES macro, and ES, we have ES and we have ESP, right? So, actually, let's make it ESP so it's also 3 letters, right? So, right, because then we have ES and we have ESP, and it's just easier to... it's just easier to undefine all this stuff, right? If it's, you know, if everything's exactly 3 letters, right? So then over in our undefined section, we can undef ESP, and I'm thinking what we want to do is I'd rather not rehash these sections. So what we should do is 2, 3, 4, 5. I don't know. Do we want to give it a different color? Color this one blue because of where it came from. I don't know. Maybe we're getting too fancy here. Probably getting too fancy. But then up here, right, we can say that this is, oh, ESP and ES, right? So, and ES. All right, so these we can give these colors, and these ones can be orange, because why not? And then over here, right, so this can be 1, and this can be 2, right? And then the numbering here can start at, you know, 3, 4, 5, and 6, right? 3, 4, 5, and 6. So we start at the common, and then these numberings start at 3, right? So if we look down here, right, we should have 3, 4, 5, 6, and the 1, 2, right? So undefine previous defines from this file. Okay. Let's make a note of this. Okay. So now that we've kind of undefined those, because we don't want those macros to leak into other code, right? And now we got our little air string macro that takes an error message, and we're using it right here. The error string. This is our error string. Right, so no quote marks anymore. Also, let's make sure that there's no quote marks kind of laying around in here. No quote marks. What about single quotes? Let's make sure there's no quote marks, no of any sort in here. This probably does not matter. But I'm kind of paranoid, so let's try to remove any type of quote mark, right? So for ownership, we'll just put it in square brackets, and then we'll put an S at the end like that. Sometimes I use asterisks for ownership, but now that looks kind of cryptic. It's like, how can you tell that's an apostrophe S? Let's just do this. Well, we could just make a note here, right? We could just make a note here that is placeholder for ownership symbol in English language, because cannot need to avoid quotes in this file because it gets stringified, right? Okay, 177, and the time is 0053, and let's just call it 54. Okay, so I think that is a good little note there for why we're doing this. Maybe it's a little bit too verbose. It's like, why do you have all these notes in your code? But like I said, we can be more verbose. We can always remove the notes later, but we can't add them after the fact. So I'm going to always err on the side of being more verbose than less. Okay, so let's give that a shot and see if everything is good. Let's close this. I don't know who's messaging me on Stack Overflow. I'm actually kind of nervous. Okay, so if we do P for pattern, we can see the pattern still, right? We can see the pattern, so we're correctly fetching the data still, right? We're correctly fetching the data. I'm convinced that that still works. And because we're doing that, we can start to take out some of the crap that we put in here, right? So in the fragment shader code for the P5D, whatever the heck, this is getting removed, right? So we can just say okay, so we're going to make a note of what we removed, but we can also make a note of what to actually use, right? And then also, this can have a plus, right? So we kind of do this visual diffing kind of a thing where, right, the pluses are in green to say, hey, good thing, bad thing, removed thing, added thing. And then in this code, we can just kind of like, we can just nuke it, right? We can get rid of this piece of code. And then the next thing we're going to target, the next thing we're going to grab and figure out how to get rid of is this, right? We're going to try to tau depot get E32. Like, I think that belongs in TAUFRAG as well. So we're going to target removing that next, but we just want to make sure that stripping that out did not lead to any type of horrible problem. And okay, cool. So P3 pattern still can see the stuff. Okay, cool. So also I want to get on Discord really quick and just check the cringe group on hold on. My connection is probably really bad. Yeah, it's pretty bad. It's not. My bit rate does not look good right now. Okay, so let's go see what Luncho is saying. Okay, look for. Oh. Cool deal. Okay. Okay. So let's keep on rolling here. So yeah, we're just gonna start cutting some more stuff out here. So this thing, get U32, is, I believe it's gonna use the pixdex thing, yeah, yep. And then it has these make int32 functions, so that needs to be refactored. It uses this texel fetch, which is like, why is this wrapped like this? And where else is this being used? Can we just take this texel fetch and put it somewhere else? We might want to put it somewhere else. Well, if we're gonna refactor this out, we can see that this get U32 function uses a texel fetch, right? Now this texel fetch really belongs as more of a even more generic than TAUFRAG. Like if we go look at the texel fetch command here, we have like a sampler, and then we have like a level of detail. It all kind of reeks of you are a very generic kind of a thing. So let's go take fragcom and put it over here for a second. So this is the fragment shader common code, and if we try to find like a texel fetch here, okay. So yeah, this is a texel fetch, but it returns a uint32. So rather than returning like RGBA in a vector, it returns a U32. So first of all, is there test code for this, right? Because if there's test code in here, then we're going to have to make it wrap stuff. Unit test code, yeah. So if we look at the unit test code, there is unit test code for this. And the unit test code actually uses that texel fetch. Okay, that's fine. To avoid kind of like screwing up our unit tests, in fragcom, common data types, let's just throw it on the bottom here, I guess. Okay. So we'll just steal all of this code, all this texel fetch code right here. We're gonna steal that, but instead of calling it P5D 10GL, right? It's going to be called it's going to be renamed to fragcom, right? Fragcom, texel fetch, fragcom, whatever, right? We also might want to make a note that this has been moved, right? So So let's remove some of these big commentaries. Let's remove some big commentaries and just say at vid IID. Right, so the video ID is 0177. The time is 1 hour, 5 minutes, and 33 minutes. So we're going to extract this comment, and then what we're going to do is we're going to go into our documentation, right? So we have documentation, right? And it is kind of hackish to do this, but the idea is to remove some visual clutter we want to remove the visual clutter without completely losing the history of what was in here, right? So the idea is that we can take this extracted comment, right? And we can just throw it in here, right? So extracted comment with the exact date and time. Right? And if we really want to know, what that was all about, right, we can go find it now, right? So extracted comment, right? So all right, we can keep the exact time that we extracted the comment, and then we can, like, kind of, like, I don't know, be decorative and say, hey, this is the comment. This is the comment that we extracted from that code, right? And now we're a little less bulky, right? And then I'm thinking we also want to extract this comment as well. So we're gonna just take this as well, and we're just going to call this one just xcom. And just because this has a little bit less room to write the details in, right? And then over here, we're going to just paste that in there, right? And then we're going to do the same thing, right? So we're going to just take this kind of hashtag section here, and we're just going to throw it in here, right? We're just kind of leaving a paper trail of what we're doing here. So it's very easy to see how everything got to where it was, right? So we can also, you know, extract in this video vid IID 0177, and the time for this is 1 hour, 8 minutes, and I say 32 seconds because I like powers of 2. And then we can kind of like put this between some lines as well. Okay, cool. So now that's a little bit cleaner. And we don't really want to change any of the functionality in here, right? It's just that we just wanted to make it a little bit nicer. Now, because this is textile fetch, it might be nice to, if we can get a little bit more room in here, I think it would be nice to be able to do this. Mark these sections as textile fetches, right? So if we just say TF is a textile fetch, or we could do, right, this is a textile fetch, this is also a textile fetch. I see. That is kind of ugly. Can we just call this XCOM too? Make that a little bit shorter. And then let's go over here. And let's kind of double label this and just say this is XCOM, right? Just because we're trying to not take up too much space here, right? And if we keep that shorter, 1, 2, 3, 4, we can go put this all the way back here like that, right? And then we have more room to kind of like do this over here like that, right? Actually, if we do one more, right? One more would be a little bit better, because then we can do TF for texel fetch, and then we can kind of like start moving this over. I know this is like a whole bunch of like, it's like Y, but I think it'll be helpful the more organized we can be here. So bitpack your pixel, yeah, there's some things cutting into our sections, but that's fine. So this is still texel fetch here. So if we could kind of like move this over a bit as well, and then call this TF for texel fetch, right? So that we can kind of like section, so we can kind of section off different parts of the code, and we know what they are, right? Because we can just highlight this and go, oh, this is texel fetching code, right? So texel fetch U32 is up here. Texel fetch U32XY takes the global X and Y coordinate on the texture, right? So rather than taking a vector, right? So this takes a vector, a global position vector. So this function and this function are the same thing. They're just take a slightly different signature, right? They're basically the same function, but one is a convenience method. So now that we have this texel fetch in here, we want to, I believe this is a helper function. So if we look at, where is this? Okay. So we're good here. Let's just try to compile. Let's kind of do this in kind of incremental steps. So we kind of cut and pasted some code. There's the possibility that some of these macros are going to be missing. 380. So let's go look at 380. Looks like some of our comment characters have screwed us over. So 380, right? We're doing this multi-line comment thing, but then right here we're actually ending the multi-line comment when we do this. So we can't really write it like that. So that does give me reason to think that maybe it would be better to kind of like write it like this, right? Put it all the way to the edge like that, which makes it a little bit more ugly. But then what we could do, is we could just keep it like that, right? And if we really want to, we could put a TF right in there, right? Ugly, but less error-prone in terms of accidentally terminating our... We don't want to accidentally terminate those multi-lines. Oh, and also we have another... We did that somewhere else as well, didn't we? I feel like we did, but maybe we didn't. Okay, so we're still compiling. Cool. I'm going to assume that it still works. Cool. So then in here, we're going to start nuking some stuff, right? So this texel fetch U32, we're just going to make these wrappers for the fragcom versions, right? So we're going to take this fragcom here, and we're just going to nuke all of this, right? Well, hold on. So why do I even have CPU pixels in here, right? Because it's not even used. And in fact, if it were used, it would actually create a whole bunch of problems for us. Okay, let's not worry about that. We just have some kind of like vestigial kind of code. That's fine. I'm not gonna fret about it. But yeah, so we're gonna go in here. We're just gonna nuke this, right? We're just gonna blow this away. We're gonna be like, okay, and then we're gonna go return, and we're gonna write it in a functional style. I usually don't do this, but the thing is that we're never gonna step through this code in a debugger. So we might as well write it in this kind of terse style that I do not usually use. I usually avoid this kind of a style of code. I usually avoid this kind of style of code of returning and calling a function directly because it makes it harder to step through a function and see what's going on. So I usually have a temp variable between calling a function and returning the value. But this is never going to be seen in a debugger, so I'm just going to not do that. Okay. So we're going to do return, and then we're going to call this function. And then we're just going to pass on the parameters, right? So U32 sampler, the global, and then the level dat always 0, right? We're just going to shove that in there like that, right? No need to do anything else besides that. And then we can just kind of like, we have just enough space to do that all as a one-liner. And then also in here, same thing, right? So this text will fetch here. Let's just call the other thing. It's kind of inadvertent the way we're doing it, but right, let's just kind of make this a wrapper as well, right? So we're going to return the fragment shader comment code, and this one is not quite enough lines, so we might want to change our style a bit there. Okay, and then we might want to change that here as well. Just for consistency with the other code, though it doesn't change the fact that that is still a problem. Levo dat always 0. Let's not worry about it. So this takes U32 sampler. Then it takes a GX, takes a GY, and then it also takes the levo dat always 0. So let's try to make this kind of consistent. I just want this signature to kind of be consistent with that signature. Okay. So if we know what we're doing, which I don't guarantee we know what we're doing at all, but if we know what we're doing, we're lucky. Then wrapping that like that, so this is calling the fragcom functions. And if we do this, this will just work, right? And so right now we're just doing some refactoring, right? We want to eventually make some rudimentary UI code, but before we do that, we need to address some of the things that just need to be refactored and reorganized. Expected, levo dat 176. So we made a mistake in our refactor. So 176 right here. Yes, we got this thing here, and then we need a comma. And then while we're here, I'm going to use this kind of a style that I kind of use when I'm writing. Right, and then we'll do the same thing over here. Right. And that's just so I don't accidentally put a lax comma. So I don't accidentally put a lax comma here, and so that the formatting also stays the same, right? I can do this. That's kind of the reason for this, so that I can do that very easily. Okay, so let's give that a shot. Or not, or you could just screw me over. I don't even know where my keyboard has focus, but not there, obviously. Let's do a git bash here, so we can just have a terminal that's always open. And then git status, actually no. Right, so now run the build script and always keep that console kind of open so that we don't have to lose focus and then accidentally start typing in our source files, because that kind of gets annoying. Okay, cool. So it looks to me that we're still correctly fetching our texels, because otherwise we would not have these patterns here. So that's cool. So the refactor is pretty much going as planned. No horrible things just yet. So we got the texel fetches. And then after the Texel fetches, there was something that was using a Texel fetch, and that's kind of like why we originally did this. So we got this get U32, right? So tau depot get U32. Oh, that's going to go in here, I think. Yeah, because this... Yeah, because this deals with the tau system, right? Fragcom, we're going to try to keep the stuff that doesn't... that just looks at pixels or looks at blocks of data, but it doesn't know what those blocks of data mean, whereas TAUFRAG... this belongs more in TAUFRAG. So TAUFRAG, PixDex, and then where is GetU32 being called from? Oh, GetU32. So that means we have a GetU32 and then we must have a GetRec, right? Yep. Okay, cool. So and these need to these actual calls will have to be used, will have to be wrapped because this system isn't going to have access to these constants, right? TAUFRAG is going to have access to these constants, but nothing else is. As I got to take a break. I'm going to take a shower probably as well. So 20 minutes. Man, I have a lot of bash scripts that just pop up. Every time I come back, there's always a bash script popping up for some reason or another. Okay, let's just end the timer. Let's just get back to work. Okay, so yeah, we're going to have to wrap these as well. Okay, let's not worry about it. One step at a time here, people. So this get rec is using the TAUFRAG stuff. So what we really want to do is take this, get rec, and then get U32. Actually, we want all these, right? So let's just take this, right? Copy it. And this should be TAUFRAG because this is going to be TAUFRAG. And it's going to be public. I think it should be public because it's a common public function we're going to use, is it not? Actually, no, because we can't publicly use these because... we can't actually publicly use these because the defines that we need to use to get at the stuff are only declared in this file, right? So let's make a note. Let's just make a note here. Right, it's a private function. This is a private function. Down here, also going to be a private function. Okay. Okay, then over here, this is also going to be a private function. So, the reason they're private is because the constants that we need to get access to are only available within this file. Right? Okay. So now that we've kind of pasted that in here, the next thing we need to do is, hey, we got this rectangle type. So first of all, we want to remove this stuff, right? We want to eventually remove this stuff. We're not going to do it right now, but at least let's highlight it, get our attention, so we know that, hey, I want to remove this stuff. I want to remove this, and I want to remove this as well, right? So let's just kind of highlight this so that it gets our attention, right? So that we'll know to kind of get rid of it eventually. Okay. So the rec type, we need to go find that and make the type defs for that. So we're just going to kind of keep everything to these kind of 3-letter type defs if we can. And in here, right, if this is fragcom rec versus poly-OGL rec. Okay, so this is TAUFRAG. It can reference fragcom. That's fine. So define rec as struct, and then this kind of thing here, right? And then over here, if it's C99 code, rather than using fragcom, we'll use the poly-OGL polyfill namespace. Okay. And then we'll say, okay, this is the 7th macro we have, right? So 7th macro. And then we also want to make sure we undeclare this, right? So now that we have this many macros, we want to go back down to, so here's our defines. We have another section with the exact same name so that we can just easily kind of find them. And we're going to say, oh, this is the rect type that we want to get rid of after we're done using it. And what else do we have to concern ourselves with? So let's get rid of that stamp. So there's a rect type. There's also an assert type. So there's an assert type in IVEC2. So let's address those. So we have define assert. We want to define IVEC2. We want to define, what else do we have in here? We got I32, that's already good. U32, do we have a U32? No. Let's worry about the exact order of these later. Right now, let's just get it in here, get it working. We can organize that later if we really care about it. We can organize that later. Okay, so now that we have these, we can go up to the top of the file, right? We can go backwards direction. We can make sure that we do not wrap around, and we can just look for the first instance of U32, which should be, or maybe not, because we have these. But U32, there we go. So uint U32 type, and that is for the C99 version of the code. So this is the C99 code, so we know that for the U32, it's going to be, oops. For the U32 type, uint32, it's going to be this. And for the IVEC2, so this is IVEC2. Has IVEC2 in the macro. This is the polyfill, one in the C99 code. For the assert actually is going to resolve to nothing. Well, the assert is assert here, but then in the GLSL code, it's going to resolve to nothing. So if we look at assert here, we can see, oh, it resolves to nothing, right? So we just say, right, so any parameters that the macro takes, we just get rid of them, right? For IVEC2 though, IVEC2, it's going to be an IVEC2, and for U32, U32 is just a uint. IVEC2, uint, nothing. Polyfill for a rectangle, true for trunk, mi3, make int32. Okay, so that all looks good to me. So let's say we got, let's fill out the new numbers. So 8, 9, and 10, right? And then let's take this, copy, go up here and paste that. Okay. And now let's go back down to where we were kind of declaring these. So after rectangle, we have these 3 new types, right? So we'll go down here to the bottom, and we'll paste these new types, and we'll kind of get this filled in here, right? So undef this stuff, right? And then what we're going to do is we're just going to, you know, pattern match with the rest of the stuff, right? So 08, 9, and 10, right? Okay. So that looks good there in terms of the defines being correctly defined, right? But now we have some of these macros in here. We're using shorter macros, right? So for this thing that says Mac F32, right? We're going to say MF3 for make float 32, right? So that's now MF3. It's just kind of what I decided on. And then this is make I32, so that's going to be make I3, MI3, so make float 32, make int 32. Okay, and let's just search for anything that says Mac, right? So anything that says Mac here, needs to be refactored, right? So this Mac I32 needs to be Mac I3. This Mac F32 needs to be Mac F3, right, for float 32. Mac F3 for float 32. Okay. This Mac I32. Let's make a note of that before we change it, right? So make int 32, so mi3. It's like by the time we have this temp, it's like, why do we even need the temp, right? Because now we can just say, we can just put it in here, right? Why not? So mi3, and then you don't even need the temp. We can just go nuke that all the way. Okay, get you 32. This needs to be not this. So this is going to be fragcom texel fetch. Okay. Now let's make sure that make float 32 and make int 32 are all kind of used correctly. So float divided by a float, right? That's what this is for. Float divided by a float, float divided by a float. Okay, so that makes sense there. What about the int 32s? So we want to convert to ints to get sx, sy. All these indices, all these pixel locations are texel locations. They all need to be integers. That makes sense. Let's change some of this indentation here. I don't know what I actually intended for the bracket balancing here. It almost looks like I wanted something like this. I don't remember, though. But we can try to do something that will look good. Okay. So that needs to be integer, so that looks good to me. Let's kind of clean this up a bit. Okay. Now, is there anything that says texel fetch that has the wrong namespace on it? So let's look for that really quick. Texel fetch. This needs to be TAUFRAG get u32. We don't want to use this texel fetch. We want to use fragcom instead, right? So fragcom. Right, and in fact, anywhere there is P5D1 OGL, anywhere there's that namespace, we don't want to use here. Okay, so that's the only instance where it's showing up. Okay, that's fine. Okay, so let's go look for where a rec is showing up. So we've kind of like refactored this code, but so we're expecting this to be correct, and then this get u32. So we have get u32, and we have get rec, right? And tau, what's tau supposed to be here? Is tau like a temporary macro? I would assume so. Oh, tau is... If we look in here, is this like hard-coded to like, tau is like a 0 or a 1? Okay. So we want to change that as well. So I know why I did that. Right, tau depot versus PAINT5D. So in here, we also want to do kind of a similar thing, except we want to make that more flexible, right? So we want to define tau in here as literally if it's the PAINT5D code, it's going to be tau depot, right? And define P5D, we want to define that as PAINT5D, right? So this is the actual texture memory that we're looking at. And then if we're in C99 code, if we're in C99 code, then what happens here is tau and PAINT5D are numbers. But rather than hard coding them as 0 or 1 here, like we're never going to change those, but we want to make this kind of like more proper. So this code actually has access to those correct numbers, right? So, and we run unit tests on those numbers, right? So I believe, yes, this still has to be hard coded here, right? But now we can take sub tau, and we can put it here, sub tau and sub P5D. Right, so sub tau, sub P5D. Right? Tau depot versus PAINT5D, so the actual texture memory versus the actual index slots for where they need to be, depending on which one of these we're using. Okay. So is there anything else we're missing? So now I realize that we have to go back down and undeclare those as well, right? So we gotta go find those, and we gotta go, oh yeah, we have 11 and 12 now, right? And it's tau and P5D that we have to undeclare. And then also here, let's just try to make sure that we have 11 and 12 here, right? So let's just keep this kind of checksum thing going, because we can easily accidentally lose track of this stuff very easily. Okay, so tau and sub are here. That's good. And now, let's match whole word so that we don't have to... Okay, so tau, and then I00 also needs to be declared. So let's go find what I00 is over here, right? I believe it's like, casted. It's an int 0. Okay. That's fine. So this is kind of annoying, right? It is annoying that we have like a very clunky kind of like adapter layer in order to get this code to work as both C99 code and GLSL code. And if we screw up this adapter layer, the mistakes probably won't get caught in our unit tests, right? Well, the shader just won't work. And so we actually need to be pretty careful about how we do this, right? So sometimes, despite however you write your code, there are going to be times at which no level of unit testing or whatever kind of test you could write could possibly catch the problems. You actually have to catch them yourself. So you just have to write the code very carefully and make sure you haven't effed it up. So I00 comes after the P5D, right? Okay. So then down at the bottom here, we want to include undef for that. Undef I00. Right, we got all these kind of very terse macros. It's a lot to keep track of. Okay. So the thing is what we've just done is we haven't actually replaced these call sites yet, right? We're getting ready to replace functionality. But before we do that, we want to just be able to throw this in here and have it compile correctly, right? So before we even start using these functions, we want to make sure that they compile. So okay, so this doesn't mean we're out of the woods yet, because we might have a syntax error, right? Yeah, so we got to look at this and be like, okay, well, what do we screw up? Undefined variable tau depot, right? Tau depot, okay. So if we copy this and we go, okay, well, where is this tau depot thingy we're talking about, right? And we can see, somewhere in here we said tau depot, right? Oh god. It's right here, tau depot. The problem is that this code, TAUFRAG, doesn't know about, in PAINT5D, in the PAINT5D shader, so if you go look at PAINT5D fragment shader, there's probably some type of define this, define that. So we're gonna, right, so different shaders may want to know about other shaders' memory for whatever reason. They might want to know, right? So rather than have to worry about these different samplers, right, Tau Depot, PAINT5D, we should just make one kind of header for this, right? And just say, like, yeah. So what we're going to do is, in here, right, we have fragcom, we have TAUFRAG. We could put it in fragcom, right? Technically, it's fragment shader common code. That could solve it, right? So if we go in fragcom, right, we could say, let's steal this from here. Common. All shaders know about all memory. They're just gonna say, you know, all shaders know about all memory, I guess. If this is OpenGL, right? So it's wrapped in this is OpenGL, so that's good. So we don't have to worry about these defines leaking somewhere else, right? And let's just say, you know, all shaders know about all other memory. And if we throw it in there, right? If we take it out of there, throw it in there, then we should get, yeah. So we're kind of like reworking stuff, but it's getting more organized, right? Right, you have to take the time to reorganize your code and make it more sensible, because if you don't take the time to do this kind of stuff, your code's just gonna become unmanageable over time, right? You're gonna make progress a lot faster in the beginning, but then your progress is going to slowly slow just a little bit every day until it just grinds to a halt. And when that happens, when your code progress finally grinds to a halt, you're going to find yourself in a mess that's almost impossible to refactor yourself out of, right? Because this little refactoring we're doing really seems like a huge undertaking. And so imagine having to refactor like a whole bunch of stuff because you like have a whole bunch of technical debt. So we gotta manage the snowfall of technical debt while it's just a few inches thick, rather than waiting for it to like be as high as a house and then trying to yeah.
You need to go sign something at the bank before the 9th of April on that one.
Okay. Oh, the PNC Bank?
Yeah. The one down in State, Michigan.
Yeah. Okay. Signature.
They just need an updated signature.
Okay.
That's the account you and Grandma have.
Yeah, I got it. Okay, thank you. Okay, let's just pin this somewhere. I got a paper clip. I just paper clip this. Alright. Can we paper clip it up here? Okay. So we're in a good situation here. Now, the thing is that we may have one of our other shaders probably needs to be a little bit reorganized now. So if we, I don't know if it's working, right? So the memory view, I think already has a cut and paste of these same macros. And so we're going to need to rework that code a little bit. Like, it might work because you can probably define... Well, we'll just try. So if we go over here, right, P for pattern, this works. But if we look at the memory viewer, yeah, the memory viewer, yeah, conflicts with, yeah, so we have some conflicts, right? So I thought that would happen. Well, I thought it might happen. I wasn't like 100% certain about it. But we need to open up our shader for the GPU view. So if we look at GPU view, and we look at the shader code for this, we have fragcom, and then we have gpu.frag.string. So let's go look at, open up GPU view. So go open up, and we're just going to find GPU view. .fragment, so we're going to find the fragment shader code, and we see this big kind of prelude thing that says GLSL file scope stuff. This stuff right here. We kind of refactored that block of code into fragcom for fragment shader common, right? GLSL file scope, and we're just going to say all shaders know about all memory, because why not? All right, and then we can have I resolution, so we can have some common uniforms in here. We can have some things that for shader toy compatibility, which really don't matter anymore because we're really not gonna try too hard to make stuff compatible with shader toy. But this can help if we want to cut paste stuff into shader toy and see if it works. So all we got to do to fix this code, because if we look at this shader. It has GPU view and already has fragment shader common, so all we should have to do is within GPU view, this GSL file scope blah 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 stuff, just take it, and we should just be able to nuke it. Just completely nuke it, take it out of there. And if we do that, those errors should be removed, and now both of our shaders will work. Okay, so now if we look at this, this shader still works, as expected. I didn't expect this to be broken. I am still worried about the first one, but let's see what we got. Oh, look at that, that works now. Okay, cool. So this is just a memory view. It's just zoomed into part of the Tau Depot texture memory. This shader is going to be used for a raw memory view of any type of data that we want, any texture allocation we want to look at. We're going to use this to look at that, and by looking at this like this, you know, you can't really read this, right, in terms of, like, I have to know exactly what I'm looking for, right? So I have to know about a certain variable that's within a certain pixel here and be able to look at it and say, is it the color that I think it should be, right? And so these colors here are not the actual RGB values. They're just, it's a special tint so that I can see it, because most of this stuff would just be black if I didn't tint it these special colors. And this just gives me a little bit better feedback to know what I'm looking at. That all looks fine to me. This looks fine to me. Right, we got all these other shader slots that aren't being used. Yeah, so we're good there. We're good there. So the next thing we want to do is let's just do git status, or not that, git status. Git add dot. And all we're going to do is we're just going to say, so say why you did what you did, not what you did, is the common convention. I don't always abide by that, because I think abiding by that always is kind of stupid. But in this case, saying why we did what we did is actually a good commit message, because what we're doing is it's just a safety save. Safety save, working commit, right? So there is a refactor in progress. This is a safety save, and this is a working commit. So if we ever want to revert backwards, we know that this is a safe location to revert backwards. Okay, so let's keep on hacking away at this. So GPUV, we can close this. We can close this GPUV thing. Fragcom, whatever the heck. I think we still want to look at that. We don't really need to look at these. We know these are the orders in which things are included. We don't need to look at that, though. And so in P5D, whatever the heck, we have these functions here that we're trying to phase out, right? So let's go find them. Or not. Or just... Oh, let me guess. Is this not referenced anywhere? Like, maybe it used to be referenced, and then... yeah, I'm gonna guess that this used to be referenced, but then I made the rectangle version of this, maybe? Is this, like, almost duplicated version of this? It kind of is. So I'm gonna guess that the rectangle version I am using, though. No? Did I already refactor this? I don't think I did. Get rec. Okay, this is suspicious as hell. So if we go here, I swear to God, I'm using that kind of code here. We got get U32 right here. We got get rec right here. Gonna throw a table here. Oh, because wraparound is turned off. That's why. Okay. So yeah, now, okay, so now we can see these calls here, right? And we want to phase this out, right? So instead of calling this, we want to... Anywhere we're calling this get rec here, right? These things here and the get U32s, we want to factor those out, and we want to actually call these. And then still this has to be moved into... but we don't even have access. These are hard-coded, so one thing at a... one thing at a time. So, well, actually, hold on. Okay, actually, we could. Okay, whatever. Let's do this first. Let's do this first. So this is going to be called TAUFRAG, right? And I made it a private function. I think I'm going to change my mind on that, but for now, let's not worry about that aspect. Let's just kind of refactor it, right? Alright, so let's refactor these. But now that they're refactored, let's just make sure that the code still works. Let's make sure that we still get... Let's make sure the shader still runs, and then we'll address the problem I'm seeing. It's not a huge problem, but it's a problem that probably needs some addressing. Implicit declaration of function AAC TAUFRAG get rec. And that is in P5D OGL main. So if we look at this, it's right here. Now, is this over here? Do we get the case wrong, maybe? Oh, yeah. So if it's a private function, then all namespaces are lowercase, right? So the project namespace and the sub namespace are lowercase. That is the convention I have established, and I'm just not abiding by that. Okay, cool. So consistent habits are better than a good memory, because unless you have a photographic memory, you're just going to write so much code that you're just going to forget what was what. And so if you can keep the code highly consistent, then you don't have to remember stuff, right? It's just like, it just works because you remembered how it needs to be, right? Okay, excellent. So now the next thing was, how do I get rid of this hard coding, right? And I was thinking that we would just make these wrappers, but then we have to make an individual wrapper function for each one of these calls, which could get really annoying. So what we could do is these things that are undefined. So these are defined no matter if it's OpenGL or C99 code. But a trick we want to do here is that we only want to undefine it if it is C99 code, right? Because we don't want the macros to leak into other code. But if it's fragment shader code, we actually do want it to leak into other codes so that we can use it, right? Ooh, that could create some problems, right? Because then the unit test won't work correctly, right? Yeah, so that's going to create some problems for us. Well, we can make this work. It's just gonna be harder. Well, let me think about it. No, that's just gonna make things. That's gonna make things complicated for us, isn't it? So we might, yeah, to make this work properly, to avoid hard coding, it'd be just better to make these helper functions. That's the best way I can think of doing it. So this P5D VP0, right? Get rec, we make overloads for these things. So let's just go in here and just say rectangle public so we're gonna just call this public rectangle getters or something like that. But they're just gonna be pretty simple wrapper functions, right? So in here, right, it's just gonna be called rec, right? Rec, and then it's going to be AAC 2020. Actually, this will be public. AAC 2020 TAUFRAG get rec, right? So get is camel case because it's like I actually mean to get something. Rec is a type. And then we want to get the PAINT5D VP0, right? So we're just going to make that lowercase just so that we have the capital that kind of helps separate this and this. That's the only really reason for making that lowercase. And then it's not actually going to take any parameters, right? So it's just going to take nothing, right? So I'd say VOD for void, and then we'll fix that once we get to it. So VOD for void, and then in here, this little wrapper here, right? We're going to take this code, and these are hard-coded right now, and we're going to fix that. We're going to fix that, but for now, we're gonna not worry about that just yet. So right, we're just going to refactor that, and then we're going to, before we refactor the other things, let's just make sure we can get this stuff to work, right? So in our kind of list of three-letter macros, we're going to add one more, right? Define VOD as void, and that's going to be the same in both languages. In GLSL code and in C99 code, it's going to be the same. So we're going to define VOD as void in both languages. And I'm already kind of worried here because VOD is 14 here. Okay, no, that's okay. Never mind. 13 and 14. Okay, and then we'll go down to the bottom where we're undefining stuff, right? And the 14th thing here is going to be VOD for void 14. Okay. Oh, also, so I was originally thinking that, you know, if this was like, there was a thought I almost considered, but I didn't verbalize it for the camera. So these constants here, right, are going to be needed to be used in here, I believe. Or at least this constant and this constant were going to be used in here. Like for tau, the tau is going to come from here, right? And to use it externally here, one way we could get that to work is, you know, if we have this block here, but then when we get to the undefs for this stuff, we only undefine it if it's C99 code, but if it's GLSL code, we keep it. And that way those defines can leak into other shader code that is included in the shader string. The problem with that is that it will wreck the parallelism between the GLSL code and the C99 code, and it could also definitely create points where the unit test code for the shader code, the unit test code that runs on the CPU side for the shader code, could start to fail because access to certain macros is assumed in the code when it's compiled as GLSL code, but then those same macros don't exist if it's compiled as C99 code, and then you just you're going to have a messy problem on your hands. So we want to basically keep this code parallel, right? We want it to function exactly the same in GLSL as in C99, so we really want to clean up all our macros after we're done using them on a file-per-file basis. Unless there's some extenuating circumstance to do otherwise. Because we got to keep this as uniform as possible. Otherwise, we're just going to end up with a whole bunch of horrible, hard-to-debug problems. Okay, so let's look at this. So shaders still work. That still works. Okay, cool. So now what we want to do is we're confident that our refactoring method here is working, right? Ouch. Okay. So we're confident that this refactor method is working, right? That the use of this getRec to create this wrapper here, we're confident that's working. So the next part is we want to take these defines, right? So we have tau015, right? And then we also have PAINT5D, but it's not going to be PAINT5D all capitals, right? So this is going to be, this is this, right? This is not PAINT5D. This is a sub, but it's going to be called sub P5D, right? So the tau is tau number 15, the sub is P5D, and then P5D VP0. So we should just be able to steal this VP0 thing, and that should be what we need. And it should be set to 1. So if we look in our hard codings somewhere in here, we should be able to find that. So this right here is hard-coded to 1, and then it's cross-checked in our unit test to make sure that hard coding is correct. So it's still hard-coded, but now it's hard-coded in a way where we can unit test to make sure that hard coding is correct, which is not the best way to do it, but it's the dirty compromise we need to get this working. So tau PAINT5D VP0, right? So we're removing this hard coding. And we're still not calling this code, right? We're still not calling this code. We know that we're confident that this refactor works, right? So if we look at this right here, this first thing, let's comment this out. Okay, let's comment this out and just try to run it, because we're going to assume that it's going to crash. We just want to, but as we kind of refactor things, we want to break things every once in a while, just to have confidence, just to have confidence that the changes we're making are actually affecting the code base, right? Because sometimes you could have like the repo in 2 different places on 2 different hard disks, and you could be editing one source file when you think you're editing another source file, and then you think, oh man, I'm making all these changes and not making any mistakes. Then you realize you're editing the wrong file, and that's horrible. So, so we're going to take this commentary, and we're going to try to make a nice little one-liner, right? Rec P5D0, whatever the heck, right? AKA P5D rec. And then we're going to just say equals. And then we can keep that commentary in here like that. And then we can call this function here, right? So we can say, hey, there's this public function. We can line this up nicely so we can see, hey, here's the VP0. So P5D VP0 is a rectangle. Get rec P5D0. So, okay, yeah. And then with that, we can get rid of some of this extra spacing and just kind of write it like this, right? And I'm happy with that. So we've made this a little bit more terse, but we can still see where everything is kind of, we can still kind of trace the connections. I'm kind of unhappy with this, right? Because this name here and this name here aren't exactly the same, but, you know, as you're shuffling things around, sometimes things just get ordered differently. So, okay, so we're going to try that, right? And if that works, then we can refactor the rest of it, right? But we just want to do one thing at a time first, just to make sure that the refactor is, that we know what we're doing. P5D VP0 undeclared. So where are you? 364 in TAUFRAG, right? So copy this for a second. And it's saying that this doesn't exist. Saying that this is bullshit. You don't exist. And we can see the reason why. It's because for some reason we decided lowercase. Why did we decide lowercase? I don't know. I don't like it. I don't think it's a good idea. So we're going to make that capital. VP0, right? Change our mind on that. P5D VP0, and this P5D VP0, same thing. VP0, make that capital. Okay, VP0. Right, now that VP0 will be recognized, right? So capital for the constant and then lowercase for the variable name, right? Which makes more sense. We can also spot check and make sure that it's assigned correctly. So if we look in here, we can see VP0 is assigned to VP0. We can see, yeah, everywhere it looks okay. Yeah, so I'm satisfied there. In cases, like, my brain is not very case sensitive. It's a little bit more case sensitive than back when I worked with, like, Visual Basic and QBasic and other case insensitive languages. But I still need to get better at it. Okay, so cool thing, still kind of working, right? Still looks good to me. So that to me says, hey, we have to go ahead to start refactoring the rest of these, right? So what we're going to do is we're going to go find the wrapper function we just wrote, right? So the wrapper function here, and we're just going to make more of these, right? So we're just going to paste this here, and this one is going to be called P5D VP1, right? So anywhere we see a VP0, we want that to now be a VP1, right? So VP1, 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 right? And this is also a VP1, right? So if we do that, then what we can do is we can comment out all of this code, and then we can make a one-liner like this, right? So this code is going to get a lot better. So VP1, rec VP1, VP1, right? Okay, so let's go give that a run and make sure that that refactor works, and then we'll do the next function. But yeah, just make a little changes, keep on going, make a little bit of changes. We want kind of a very slow, steady, get it right kind of a style here. So implicit declaration of function get rec P5D VP1. Okay. So I'm a little bit confused because I see it there. So the first thing is let's copy this, right? And let's go see if maybe perhaps we've spelled something incorrectly. Oh, no, we haven't. It's that we did not save that file. Okay, so now if we do this, this should work. And then the @hardcoded we can actually remove those @hardcodeds because this is no longer hard-coded. P5D VP1 undeclared, and right, so the reason for that, right, is because we did this lowercase nonsense for some reason. I don't know why that's the case, but we're going to say VP1, right? We're going to make this uppercase. And then over here, this is also going to be VP1. This is going to be uppercase as well. We're not going to worry about the other macros for now. We're just going to fix what we need to fix, right? Okay. So now we can just get this working. And then viewport canvas is the next thing I think we have to refactor, right? We'll just keep on doing it and then slowly make progress. Okay, so it still looks good. Still looks like this is working, right? Excellent. So what's next? So we got this thing. So what I really want to do is the thing that says hard-coded, it's not hard-coded anymore. Not on this side of the screen, right? Not on the right side of the screen. This isn't hard-coded anymore. Let's remove that hard-coded nonsense, right? It's not hard-coded anymore. Let's save ourselves some space, and then let's make a little index here. Right, let's make a mini index. And we're not going to do forward declarations here. It's just a mini index in the comments. Right? Mini local function index. Okay. And we're just going to paste the names of these just to make things a little bit easier, right? So, okay. And then the third thing we're about to do is, I believe, VPC probably, right? TAUFRAG, something, something. Oh no, offset dex. This is offset dex according to the comments. So this will be, instead of rec, this isn't going to be rec. This is going to be like get U32, right? So get U32. Okay, and the type that we want to get is called P5D AD for offset dex. And then we also want to comment this out, so we want to go boom, boom, boom. Okay. So let's work on that wrapper. We want to take this code, we want to take all this code, even the hard-coded comment, and we want to just paste that there, and then we want to wrap it, right? So let's take this rec thing. It's not going to be a rec, it's going to be a U32 this time. And so instead of get rec, it's going to be get U32, and then it's going to be P5D, and then AD for offset decks, right? Right, because we got this P5D AD right here. So then, osdex equals this. That's fine. And then we're going to return osdex. Okay. And then, make int32 has to be make int32 like this, because our macros are shorter in this file. And then we can take one from our notes of what these different defines are supposed to be, these different hard-coded things. We can unhard-code them. And then P5D AD, let's go look for what that should be, right? So P5D AD is already defined as a number here, right? And if we look at what the number is, right, we can find this thing var, whatever the heck, and it says it's 9. Okay, so if we go back to where we're kind of doing this stuff, we can see, oh, hey, look, that's 9. Excellent. So this right here needs to be P5D AD, which resolves to 9, and then we can get rid of that hard coding, right? So that note to say get rid of this hard coding, well, we just got rid of it, so we can remove that note, right? Get rid of define hardcodes. Well, we got rid of that. So this commentary, also not needed. So osdex U32 versus just osdex, which is probably a int32. Yeah, osdex int32. Well, hold the heck on here. Which one of these are we using? We're just using osdex int32? Are we using this anywhere? Osdex is... So we're using an int32 here, aren't we? Yeah, we're using an int32. Now, why is it an int32? Because ints are just easier to work with. That's really the only reason. An integer is easier to work with than an unsigned integer, because when you just see a random integer in your code, GLSL assumes that it's an integer. GLSL assumes that an integer is a signed integer by default. And working with unsigned integers, unless you absolutely have to have them unsigned because you're doing bit packing, working with unsigned integers is just a pain because you always have to wrap them in a cast. Otherwise, GLSL will complain. So this function here is not named this. It's going to be int32, and we're not going to call it get u32. It's going to be get int32, right? And that's good there. That's actually what it needs to be. I was wondering why the signature didn't quite match. And so we're going to work on replacing this, but I'm a little bit lacking in confidence right now. So let's run this again, and then we'll complete the refactor there, and then we'll kind of look at what else we need to kind of get out of here. Okay. So P for pattern, go through the different layers. Looks like everything's still there to me. I don't see anything highly detrimental. So now, this hard-coded stuff, we're going to comment this out. We're going to comment this out right here, and then we're going to say, okay, we're going to say int32 osdex, right? The active offset dex, right? So aka that should be the thing. And we should just be able to use TAUFRAG, right? The public TAUFRAG function. Get int32 P5D AD, right? And we should just be able to use that. And if we're really good about this, we can line this up. We can line this up so we can see those both right in the same position. And lo and behold, that looks like the other code we wrote. So let's kind of line that up like that, just because, I don't know, I like that. Okay. So let's make sure that works, and then we can, once this works, we can blast away all this kind of code on the left monitor, right? Because we've slowly refactored it to where it needs to be. Okay, cool. So now that that's all taken care of, we can, these hard-coded things that we needed to fix, they're fixed. We can nuke this. We can nuke this code. And we can nuke this code. Right? So get variables stored in texture, much more readable. Much more of a high-level summary now, right? Let's not cram it all together like that. Let's keep some space, right? So much more condensed, right? So VP0, VP1, right? If we want to highlight these really quick and make sure that the numbers make sense, right? We can do that. We can have a little sanity check here. We can also do a little sanity check here. So this is VP0, this is VP1, this is AD. So the offset dex is a little bit non-uniform in the way we wrote it, because we got P5D this, P5D this, and this is like osdex equals this, which is kind of like eh. But I understand what it means. I kind of get why I wrote it that way, because osdex is a little bit more makey sensey than this variable. Okay. But it is kind of like not completely uniform. But oh well. Code's not going to be completely perfect, right? We're going to aspire to perfection, and then we're going to fall short. That's what we're going to do. And the weird part about aspiring to perfection and falling short is that even though you know you're going to fall short, you still have to aspire towards perfection. You can't say, I know I'm going to fall short, therefore I'm not going to try because I know I'm not going to do it, right? You have to, despite knowing that it's not going to happen, that you're not going to reach perfection, you still have to strive towards perfection. So it's this weird thing where it's very paradoxical, right? But that's the way it is. So it's like, you know you're destined to fail, right? If you could tell the future and knew you're destined to fail, would you try at all, right? And the answer is you better still try, because if you're destined to fail and you don't try, then what happens? You just fail harder than you would have failed otherwise. So just because you know you're going to screw up and fail doesn't mean you shouldn't try, because you could just end up failing even harder if you don't try. Okay, yeah, so that looks good. And the shaders here, this shader's still here, these shaders are still here, excellent. So that's kind of like, yeah, and we got all the names, except I think this name might not have been refactored correctly. So let's throw that name in there. Okay, that's good. And then also maybe put like a dash line I3x64, or actually no. Dash line I4x64, and the reason why we have an I4 is because we want a little padding right here at the end, because how we're going to wrap everything in a string. Okay, right, and so I'm just kind of like making little dividers between little different functions in this section. Okay, so that looks good, right? Everything is kind of like, this is very clunky, very verbose, but it's okay if it's verbose as long as we can understand exactly what's going on. Okay, so that's refactored out of there. There's some other crap in here. I feel like there's some more stuff we have to look at though, right? So we got that refactored, but there should be like some functions that we need to strip out of the code still. And I know they're probably colored, or maybe I forgot to color them. let's just go P5D1OGL, right? There's some functions I know I need to remove. Not this one. Let's stop going backwards through the code. That's getting really annoying. Okay, so let's just start at the top of the code. Let's not wrap around, and let's just go through one at a time and stop at any function that we know needs to be ripped out. So this text will fetch, yes, I would like to rip it out because it's just a wrapper function now, but it needs to be here because it's ran in our unit test, so we got to keep it. Tau depot get u32. I believe this needs to be ripped out. So if we look at this, let's color this. Actually, let's remove all the color coding. And tau depot get u32. First of all, let's see if it's called anywhere. Nope. Okay. And then, what about down here? I bet this get rec as well. Probably not called anywhere anymore, right? Because we refactored that out of the code base, right? So the get rec code is actually in the fragcom now, right? So not in fragcom, but so if you look at get rec, if we look for get rec, it's in here. Get rec, right? We made it in here, right? So TAUFRAG get rec, it's been kind of put in here. So we're gonna make a note though of what we're removing, right? So we're removing this and we're removing this. So let's make some more removed notes, right? So we can keep track of right, of what was removed and what you want to use instead of this, right? So the get u32 is removed, and instead of using get u32, we want you to use this, right? And so we can kind of try to line it up so we can see the names line up where they should. Right, so this is removed. And then over here, this function as well, we're going to remove. So we'll make a note about that as well. So this is removed, and what do we want to use instead? And for the get rec, get u32, and then the get rec, which utilizes that, we want to use this function, right? And these are actually private functions, so we never actually want to use them from this code. But let's just not worry about that small detail, right? So we have a note of what's been removed, and then we can just take this, right? The get rec all the way down to, wait, tau depot get rec. What the hell? Tau depot get rec. How the hell? This is definitely get rec. Has this code just been cut and pasted twice? No, this is... Oh, no, this is get u32. Oh, because this is... Oops, when I was cutting and pasting. Okay. Yeah, so here's get u32, here's get rec. We're just going to blast these away. Okay. And then we're going to make a note of... ID 46. Let's just say 47. Fetching data from texture memory is now all in TAUFRAG.frag underscore, right? So we'll just make a note of where that is now. And I'm happy with that. So let's make sure this still compiles, and then we've kind of achieved one of the goals for what we wanted to do. And then I think I'm going to try to think about, say, hey, I got a checkpoint in terms of the engine code I've worked on, and now I want to focus on the Decton table kind of stuff, try to figure out how the hell I'm going to make money on Etsy. Because I think this engine, I honestly think this engine, I know it doesn't look like much yet, but I honestly think the engine I'm working on, right, has the ability to make millions of dollars. Like, that is, I mean, maybe I just have narcissistic personality disorder or whatever, right? But yeah, I do believe this. I've had this engine idea for 8 years, right? So it's been this idea that's kind of obsessed me. And I do think it has that kind of profit potential. But it's going to be a long time before it gets to be that awesome to where it'll start to shine. So in the meantime, we can't be waiting 10 years for this to be making millions of dollars. So we think it's that good enough. It's a good enough idea, but it's just going to take a lot of time to get that to pay out, right? So in the meantime, we got to figure out how to make money on Etsy with other things. So we're gonna commit what we have, and then we're gonna look at our checklist, edit our checklist for this, and then we're gonna get on to Etsy stuff. We'll do another stream for that because it's not related to the code base, right? So I don't know why I just ran that again. That's not what I wanted to do. Git status. Git add dot. Git commit dash am. Refactor, TAUFRAG, shader, refactor, finished, right? So we just finished that refactor. We've gotten rid of a lot of hard-coded variables. Git push GitHub master. Okay. And then also, let's push this up to Kanji Coder, right? It's in a stable state. We can push it up to the public. And then we'll look at our checklist. Actually, we can look at our checklist right now while we're waiting for that to push up. Fragcom functions that use tau depot must be moved into TAUFRAG. So I don't know if I did that. So it's saying if it's a frag common function and it uses tau depot, it needs to be moved into text will fetch is a generic function. Yeah, so I don't see any of that. Let me look for tau, right? Tau would be in here. Tau depot, tau depot, tau 0 and 1. Okay, that's fine. I'm not going to worry about factoring these out. Okay, yeah, let's not worry about cleaning that up for now. Actually, here, you know what we can do? Can we just do this? Can we put square brackets around it? Will that compile correctly? Will that compile correctly, or will that just say? Will that? So I just want to put square brackets around it to make it fail, right? To say it used to be this, but do not use it is what I want that to mean. So if we do like /AAC2020.sh, if we try to compile it like that and we make that macro to resolve to that, as long as we don't use it, will that be okay, or will the compiler complain at us? Either the GLSL compiler or the C99 compiler. If any one of those complains at us, then we have a problem. And it does not look like that complained. Okay, so we're going to kind of do that, right? So this tau and this P5D we do not actually want to use within here. So we're gonna just do this, right? And so we don't just want one. We don't want this to accidentally look like array access. So we want to do two of these, so that's invalid syntax, right? So tau in P5D, and we also want to make sure that it's not used in C99 code or GLSL code. So we want to find so this is the GLSL code. We also want to find the C99 code, and we want to do the same thing, right? So we want to just say put two square brackets around it, so that it does not compile. Okay. And we're going to not know why that is in the future, right? We're going to be confused as heck. So what we could do is, let's try to make a note of this in our documentation. Just put it somewhere. So if we like search for this, we can kind of figure out why the heck this is. So let's just take these defines for these pieces of data, and what's double square bracket macros. So we'll make a little commentary file, a little commentary section about what the heck this is about, so that if we ever had this mystery and we want to find it, right, and if we dig deep enough, we've left a paper trail to explain what this is about. So O5, let's just do 13. When we decide a macro should not be used, we surround it in double square brackets to intentionally cause compiler error if the macro value is referenced. Usually we do something like define don't use this my macro, don't use this macro, but we can't use that strategy in fragment shader code because fragment shader code must be wrapped in a string, and the double quote characters will destroy my pre-processing steps. Right. So basically, this stuff right here, this is just a different way of doing something like this. Like define my macro, don't use this macro, right? Now this is much more readable and self-documenting, but it contains quote characters, and in code that needs to be stringified by my pre-processing steps, I can't have double quotes in the source code, so this is kind of the same way to get the same effect. but it's more cryptic, right? So it's a way that I would like to avoid unless I would like to do the other way, but if I can't do the other way, then we choose this alternative, more cryptic way of doing things, right? So then what we could do is we could take this, right? And if we really want to, we could go and we could put a commentary here, right? We could, if we really want to leave leave a note for ourselves, we could say hashtag double square bracket macros, right? We could do that. We could leave a little visual space here, right, like that. And then we could just, right, leave ourselves a little paper trail. I kind of like that. Let's just do that, right? So then over here, same kind of deal. So let's leave another paper trail for ourselves. So let's go throw this in here into a comment, right? So we can find that comment in the extracted hashtag commentary documentation file. Now, if we really want to know what these double square brackets are, we see, oh, double square bracket macros. This is probably a commentary about what this nonsense is all about, right? So we don't have to put a big, huge block comment right here in the code. We just can offboard this tag to that commentary, right? Okay, so now that we've cleaned that up and left ourselves a nice little paper trail for being able to find that, we want to recompile. We want to rerun the project. If the project runs, we're going to commit it. And then we're going to commit it. We'll check our checklist again. And then we'll work on the Dectin code, or the Dectin stuff. So git status, okay, git add dot, git commit dash am, double square bracket macros. So I'm actually going to use the exact same text string that I put here in the commit message, right? So that it's easy to connect the dots between the commit message and the code here that I wrote in the commentary file, right? Like we want to be able to easily understanding code is all about connecting the dots, right? Figuring out how one piece of information links to another piece of information and figuring out that chain of cause and effect. So when we're writing the code, we want to write the code in a way where we're intentionally making it easier to understand that chain of cause and effect. So git push GitHub, and then we'll also push this up to Conjure Coder. We'll look at our checklist again, and then once we're satisfied, okay, so let's go look at our checklist while that's pushing up. Fragcom functions that use TAUDIPA must be moved to TAUFRAG. That's kind of what we did. GPU library should be fine in current position. Yeah, I'm fine with that. UI Rex is what we want to work on next, right? So before we worked on UI Rex, we wanted to clean up the current code we already had to have like we want a nice solid foundation before we try to work on this kind of hackish UI idea that we think we have, because it's probably going to be ugly. The UI that we want to make is going to be ugly, but at the very least, at least we can make it dead simple, right? So we're going to make an ugly UI, but it's going to work for our needs, but it's just going to be ugly. Okay, the con, it's going to be an ugly code. Pros, it's going to be dead simple. Pro, it's going to work, right? It's going to it's kind of like Windows Server, right? Windows Server, the UI looks like crap because they don't want to spend extra processing power and making stuff look pretty because it's a server, right? And a server, the user interface doesn't really matter for the server, for a server, right? You just want to log into the server, do what you need to do. And so Windows Server, if you've ever used Windows Server, you might notice that, hey, that's weird. The UI looks like Windows 98. What's up with that? And the reason is when you're talking about system administration, we don't care what things look like. We care that they work, right? presentation doesn't matter, right? Presentation is more of a mass consumer kind of a thing, right? Where people care about presentation. People who have no, what do you call it, frame of reference for what is good and what's not good, they have to judge things based on things that they can relate to. So, like, there's this one coder who does freelance coding, and he activates to just keep your apartment like super clean and spotless, because the people who are going to ask for you to write code for them, they don't understand code at all, right? So they're just going to see your apartment and say, "Oh man, their code is super. Their apartment is super organized and clean. Therefore, their code must be super organized and clean." Now, I kind of disagree with the logic there, but I understand why you would want to use that logic to get hired to get customers, right? The reason I disagree with that logic is because the physical reality of my life is not organized, right? It's because I put all my experience points and all my movement points into organizing my code, and then everything else doesn't get enough attention, right? Because you have a limited amount of energy. So I sometimes think that, man, that guy probably has a spotless apartment, but his code probably looks like shit because he puts all his energy into making everything else look nice around it. But maybe I'm just full of shade, and maybe he is just awesome and I suck, whatever, I don't know. But do what you got to do to survive. I'm not knocking the way he has found to survive, right? If you're surviving, you're surviving. So you're doing something right if you're getting clients and you're getting money, right? Okay. Yeah, so I think we're about ready. Let's look at that agenda one more time. That's the agenda for today. Black market memes, TAUFRAG stubbed in. So let's redo this to-do. One. Acrylic filler scaffolding for table. That's what we want to do. That's the only thing we want to do for today on my to-do today list. This is all I want to get done. We already did this stuff. We might have to recommit this. I just kind of shuffled a few things around really quick. It's just formatting changes. And then also make sure that it still runs, right? Because we've made some changes, might not run. Okay, ./AAC2020.sh. Make sure that it still runs. I know that it's like, oh, I just changed one line of code, or I just, I didn't change the functionality. You can say that to yourself, but I've far too many times I've done something that I thought was completely trivial, and then end up blowing something up. So we don't want to make absolutely sure we don't leave the code broken. So that looks good to me. I'm satisfied. Let's nuke all this. Let's just close this. Let's close this and move on with our life. So we're going to go into the UPAT folder. Actually, we're going to stop the stream, though, because this utility patent stuff is a different category of stuff. So we're going to stop this stream. This was stream number 177 for kind of PAINT5D stuff. Yeah, we're gonna stop the stream, and we're gonna start a new stream soon.